Welcome back, everybody. We're going to get started. You are in track 1, in case you wondered. Next up, we've got Jessie Daubner and Phil Nielsen giving us a talk on how we built a data lake and warehouse using AWS Glue. So, welcome to the stage.
Hi, and thanks for joining us as we talk about our experience using AWS Glue to build a data lake and data warehouse. Just out of curiosity, has anybody used Glue? Are you using it in production? Okay, a couple people. Very cool. Okay, so first we're just going to give a little bit of the context of who we are and who Genera is. Especially because we're a small startup, and that played a big role in us deciding to use Glue as our ETL tool. And then we're going to talk about several of the challenges and solutions we came up with to help us mitigate issues we saw with using Glue. We will have time for questions at the end, so if you have those, please hold them for then. So I'm Jessie Daubner. I'm a lead data scientist at Genera, and I'm here with Phil Nielsen, who's a DevOps engineer. I'm going to focus mostly on the data management and ETL development process, mostly from a data engineering perspective. Any data scientists in the house? I know we're in an ops space here. No? No one? One? I see you. I see you. And Phil's going to focus more on the operational side of things and talk about how he helped automate processes around our analytics flows and specifically how he made things easier for data scientists. So a little bit about Genera. Genera has a real-time data exchange and analytics platform for travel providers like airlines and hotels. For example, our main goal is to process data from airlines and hotels, including customers and reservation data in real time in order to create a single unified customer and trip. For example, have any of you ever had a delayed flight and then gotten to your hotel and found that your room had already been given away? Okay, I see a few heads nodding. So with Genera, our travel providers, mainly hotels in this case, could subscribe to your travel data so that they would know that your trip was simply delayed, that you were going to show up at your hotel and not give away your hotel room. So that's one use case that we're hoping to help our brands implement to make the customer experience a little bit better. So why Glue? So for us, our initial focus was making sure that our online platform processing events in real time was stable. And then after that, we wanted to focus on offline analytics and answering bigger questions and figuring out how we could start mining data over time to get a better understanding of customers and where we could help our travel providers optimize the customer experience. For us, that started with using Kinesis Firehoses and querying data on Athena using Redshift Spectrum and connecting that to Looker. Unfortunately, that wasn't really a viable solution in the long term. We had dashboards that were taking 30 minutes to an hour to load for executives. That wasn't really acceptable. So this wasn't a solution we could use long term. We figured out we needed to use an ETL tool. We needed to combine data sets from different sources to get a fuller picture of our data. So first, a little bit about Glue. It's a fully managed serverless data integration service for developers and data scientists. It has 3 main components. First is the data catalog. So this is essentially an index of all of your data across AWS stores. So Glue crawlers can access data in Athena, Redshift, S3, anything that it can connect to through a JDBC connection. And it integrates fully with Athena. So since we had already been using Athena very heavily for ad hoc queries, the Glue data catalog actually replaces the Athena metastore in this case. So any table created in Athena via the console is effectively in the Glue data catalog. Second is the Serverless Engine. So these are Spark jobs or Python shell scripts. For us, we use PySpark very heavily, and we were very comfortable with this, using this from EMR. But from our production experience, we were pretty tired with managing EMR configurations. So the idea of being able to still use a technology that we knew really well and not have to deal with the ops overhead of that was very appealing. One of the issues with this being a serverless engine is, in theory, it should auto-scale and you should only be paying for what you use. Unfortunately, that feature doesn't quite exist right now. You basically specify a maximum amount of DPUs or data processing units that a job can use up. It may not use all of those resources, but you will pay for all of them at this time. So I know that's something AWS is working on, but it isn't quite the cost-saving promise that you might get with other serverless tools because of that. Lastly, it has its own orchestration tool. So through a series of Glue triggers, you can run jobs defined in Glue as on-demand, conditional, so you can create complex data flows where jobs have to wait for other jobs to finish before they can run. Or you can also use any sort of normal cron scheduling. So for those of you at AWS Summit just last month, you might recognize this slide. This is exactly how AWS markets Glue. And basically the gist is it's faster, cheaper, cost-effective, it's fully managed. These things were really appealing to us because we're a small resource-constrained startup, so we had 2 data scientists doing most of the ETL development and data engineering work throughout this process, and we had the help of one DevOps engineer, this guy. So the appeal of a service that could enable us as a small team to actually develop an enterprise-level data lake and data warehouse was super appealing. We also were familiar with pretty big EMR costs, so the idea of having any cost savings while still using Spark was definitely appealing too. So a little bit about our architecture to give you more context of our setup. So the Genera platform is a series of Golang microservices. We use DynamoDB very heavily operationally to perform the record linkage in real time. For analytics, we use RDS and Kinesis Firehose, which write directly to S3. These are specifically more designed for analytics, so when we figured out that we needed either questions we needed to answer for contractual reasons or things that we needed to make sure that we were keeping track of over time so that we did have valuable data to mine later on, we turned to RDS and Kinesis Firehose. You'll see the spider icon, that is the glue crawler. So in order to actually use a specific data source, whether it's a table in DynamoDB or a data set on S3, you need to crawl it. That's true for the source and the target, so you'll see that you also crawl your Redshift databases. For us, we still use Athena really heavily as an ad hoc service for QA, but we have shifted most of our reporting to Redshift now. We also have started using Sagemaker really heavily, connecting that to data in Redshift as we start exploring prototypes to try to answer questions like how valuable is a specific customer to a specific brand, how loyal are they, how much of their spend have we seen them over the past few years stick with a specific brand. And then on the top, although we have the Glue engine as sort of the central piece of our ETL, we have had to have a couple workarounds that we'll talk about a little later on, and part of that is GlueTil, which is a library that we use in a Lambda service to help us with some of the failings of the Glue crawler, and also kind of a sidecar ETL process with Fargate and CircleCI. So we're going to go over a couple of the challenges we've faced and solutions, but by no means are we saying we've really solved these problems. Some of these you just need to live with if you're using this as a managed service, like with other AWS services. Having that said, we've been using Glue in production heavily over the last 8 months, and even during that time period, things have evolved quickly. So some of these solutions may not be necessary in the near future if AWS continues to put resources into Glue, and hopefully they do. So initially, for us, the first problem was the glue crawler. So we use Terraform to manage all of our infrastructure, which you saw on the architecture diagram. And one of the lack of feature support that Terraform has is you cannot write Kinesis Firehoses in JSON to S3 in a way that allows you to prefix the data in a way that is compliant with the Hive metastore. So that key equals value formatting for keys on S3. This is a problem because Glue can't crawl that data then. And if Glue can't crawl that data, we can't load it into Redshift through Glue. The other issue we had is even for data sets that do use that Hive style, we had some complex, gnarly data that actually broke the crawler. For instance, one of the feature engineering tricks we do in our pipeline is that we tokenize all addresses that we get, and we count specific tokens across those expansions. And we use that later down the pipeline to calculate cosine similarity when we want to compare specific customers. This is problematic because for us, it essentially creates a map with keys of an unlimited number, and you can't tell Glue to not crawl a specific JSON field, so it ends up trying to index every key in this map, and after a few hours, it just chokes and gives up. So the solution that we came up with this is to run a Lambda using custom code that we wrote in a Python library that uses the Bodo3 SDK in conjunction with the Glue API that actually loads not only the non-Hive styled partitions, but also Hive style partitions. And this is important because we'd actually originally been using the Athena API with a Lambda to do this, but when we had to rebuild tables because either we were changing the DDLs, it would take hours for some of our larger tables to actually reload all the data partitions. Using the Glue API, it takes under a minute. So there was really a big performance gain here from just making that switch. Some other issues we run into is sometimes if you make a configuration error, especially if you're manually defining an Athena table and you leave off a parentheses in the or leave off a slash in the location specification, you might have a Glue crawler run amok. And basically this will create very quickly hundreds of new tables in your metastore. And so we also have a lot of helpers in this library that help you clean up things when Glue hasn't worked out quite as you hoped it would. One of the second challenges we ran into from a development perspective was just managed PySpark. So AWS's kind of selling point for its managed PySpark is its DynamicFrames API. So this is a higher level abstraction on top of the Apache Spark, Spark SQL, DynamicFrames API, and essentially the DynamicFrames API allow you to not specify a schema for specific data frame, unlike Spark SQL data frames in which you actually have to either specify a schema or you have to pass through the data twice, once for the schema to be inferred or the second time to actually load the data. And when AWS says there's a lot of cost savings or better performance, this is what they mean. Unfortunately for us, the specific use case they have for this, or at least that is the one where they say, this like DynamicFrames is like a 10x performance improvement over Apache Spark. It's actually reading messy JSON data where specific keys have different data types or might be null in specific cases, and writing that data to Parquet. That isn't a use case that we have. For us, it's pretty straightforward and common. It is loading data from S3 into Redshift, and we don't really see any performance gain from that. One thing we have found really helpful with Managed PySpark is the bookmark feature, which is really part of the AWS Glue ETL job itself. So for reading in data on S3, AWS will keep track of the last the last modified timestamp of the data you've run in so that you are only reading in deltas from S3 or newly received data from the Kinesis Firehoses. The one gotcha with this is if you are moving data across S3 for any reason, that modified timestamp will change, and then you need to be mindful of that because you'll have to reload your table, otherwise you will just have loaded a lot of duplicate data. However, one problem with the bookmarks gets into the next issue. There is no visibility into them whatsoever. For a given job, there is no way for you to see what place that AWS thinks your job is actually at. And this is kind of in a vein of overall observability is pretty difficult with this. So first of all, this is a serverless, it's serverless Spark. So you have no access to the Spark GUI because you're not managing the servers. That's really difficult for developing Spark because all of a sudden we lose a lot of the granularity of being able to see which specific tasks are having bottlenecks, how much memory is actually being used by specific executors, are the parameters that are specified useful or do they need to be tuned? And the other thing that goes hand in hand with that is AWS doesn't recommend that you actually tune any of your Spark jobs whatsoever. So this is another issue that's just really difficult to overcome because in order to have highly performant Spark jobs, they need to be tuned. Like the application parameters are specific to the data that you're loading. This is really difficult for us because we are ingesting data from a real-time platform, and that can vary greatly depending on specific data flows for a given publisher and the cyclicality of the industry we're in. So we really need a lot more control, and that's something you definitely lose when developing PySpark jobs with Glue. Lastly, and this is really the most frustrating for us, is there just are a lot of bugs and known errors. So it's pretty frequent that we'll get PagerDuty alerts over something like a network interface error. So something that is supposed to be part of the managed service that we have absolutely no control over that's killing jobs. Unfortunately, the response that we've gotten from AWS on this has been, set the retry parameter on your jobs to more than 0. So basically they're just saying run it again and run it again. And this is pretty expensive, especially on large data loads. So that's definitely a frustration that we have. Another is that, and this is true no matter whether you're using Glue or just vanilla Apache Spark, but we use the Databricks Redshift connector library, and what this library does is it transforms all of your data, writes that to a temporary S3 directory, and then it performs a Redshift copy command into Redshift when you're actually loading the data. Because S3 is eventually consistent, it's not uncommon to get a lot of S3 errors saying, this key doesn't exist because you're trying to read data that you just wrote, and that's the S3 model. There is one solution that we have developed as a workaround for this, which is sort of the hacker you have to get used to if you want to live in the AWS managed services world. But we have a custom retry decorator, which we decorate all of our write to Redshift functions with. So basically you have to dig into the Spark traceback, identify the specific error message that you know is a known issue and that AWS has said that Databricks needs to fix, and continue to retry that specific function until the write to Redshift was actually successful. This isn't great, but it at least saves us the trouble of the entire job dying and have to go through the costly steps of reading the data from S3 again, writing it to S3 again, and at least it gives us at least a little bit more leniency.
So all of that was great, and Jessie, they had a lot of work to kind of find all of those issues, but as a DevOps engineer, it was kind of my job to help enable her find those issues, debug them, and move on from there. In order to do that with the Glue ETL jobs, what AWS prescribes is using Zeppelin and dev endpoints. Zeppelin, for those of you that aren't aware, is a notebooking software that kind of provides a Python playground for our data scientists to actually work on different scripts that they're going to eventually turn into ETLs. And dev endpoints is the AWS managed PySpark kind of development environment that is supposed to mimic what their Glue ETL jobs look like. So you can combine those, connect them together, and then everything is great. Except for sometimes it's not. Oh, there we go. What we found was that when using Zeppelin notebooks, as you can see on the left here, there's a lot of manual steps involved with creation. First of all, the Zeppelin notebooks are only creatable in the console. As Jessie said before, we use Terraform for all of our infrastructure, and because there's no API support for Zeppelin notebook creation, we couldn't actually, contribute back to Terraform and, create a repeatable way to create these. So actually what Zeppelin is doing under the hood when you create them in console is just creating a nice CloudFormation template for you. And then so it's not really managed in that sense. It's still running in your environment and you still have to debug what's going on. And even after that CloudFormation template runs, there's still manual steps required for actually getting Zeppelin up and running. So for example, they have to log on, create their users for Zeppelin, and also configure SSL and configure the connection to the Glue dev endpoint. And let me tell you, I didn't see very many data scientists earlier. They don't want to actually configure SSL every morning when they come in to start their Zeppelin notebook. The other big thing that we found with Zeppelin is that it becomes really expensive if you leave it running, especially if you have a bunch of different data scientists developing ETLs. And since there was a lot of manual steps involved with creating them, this actually meant that they weren't getting stopped, and we'd spend a lot of time, they'd develop an ETL, and then a notebook would get left running for a long period of time, and that would cost a lot of money, and in a serverless world, we shouldn't have to pay money for something we're not using. So what we found as a solution was Amazon quietly announced their connection for Sagemaker notebooks to Glue. And so what Sagemaker is kind of a managed machine learning platform that AWS has really been pushing. They have a lot of different features. I know there's a talk later today about that might touch on a little bit of it. But what we found was that the Sagemaker notebooks were really useful for developing ETLs because, first of all, they were completely managed. And so that meant that they ran in our environment. We could actually control access to them with IAM controls instead of manually having our data scientists create users for the Zeppelin notebooks. We could actually just use our existing SSO within Amazon and create IAM roles that give access to these SageMaker notebooks, which is super useful from a security perspective if you have different levels of access for your different data scientists. Also, it actually had actual API support, which meant that we could create a real easy way for our data scientists to create these notebooks in a fast and easy way, which meant that things weren't left up as much, and we could actually create and destroy. So what we did was we created the CLI tool that you see on the right up here, and what that does is that our data scientists could come in the morning, say, create me a SageMaker notebook with a dev endpoint of a certain size, and off they went, and they could create all of their ETLs within there. And it was super useful. It was super nice for our data scientists to not have to worry about any of the configuration aspects. Oh, am I going to have a notebook today in time for the 11 o'clock meeting or whatever? You could actually have everything ready for them at the touch of their fingers. But what happens if you also still don't like high AWS bills from leaving these SageMaker notebooks up and running? The entire benefit of using these Glue dev endpoints over running your own Spark cluster for your ETL development is that you shouldn't be paying for things that you aren't actually using. Occasionally things would still get left up, and so what we would ended up finding was that over nights and weekends that still things were being left for a long period of time when our data scientists weren't using them, and so we kind of wanted to figure out a way to save us as a small startup, save us a bunch of money. So what we came up with was a SageMaker step function. So basically, we created a bunch of Lambda functions that use some of the libraries from our CLI tool, and in the morning, it would trigger a CloudFormation, or a CloudWatch, excuse me, CloudWatch time trigger that would actually send off the creation steps of creating a dev endpoint, creating a Sagemaker notebook, and configuring everything with all the right user access controls and everything so that our data scientists could be off and running without having to do anything themselves. And then at night, you would do another CloudWatch time trigger, and it would shut everything down for you. So, and that way you're saving a ton of money. Our glue spend from when, before this was implemented and then after was about 1/5 of the cost, which was super nice from our finance guys. They were very happy. Yeah. So the next issue that we had when creating these, our data warehouse using Glue was creating derive tables on a Redshift cluster. So a derive table in our parlance was we ingested a bunch of raw data into our Redshift cluster, but occasionally we want to combine those data sets into something that's easily repeatable and looked at from our Looker BI tool. But in order to create those, you have to run a bunch of like SQL joins, and we didn't want our data scientists to have to manually run those every day, which was initially what we were doing. But Amazon didn't actually give an easy way to run Python shell scripts on your Redshift cluster initially. And so what we did was we created this kind of like hacked around solution with CircleCI, which is our current build tool, to kind of create a scheduler that would then kick off a bunch of different ECS tasks, which was super nice because it was all controlled in GitHub. So anytime that our data scientists wanted to change a schedule, add a new job, take a job away, and change that around, it was easily accessible to them, and they didn't have to do anything from like a permissions perspective or anything like that. They were able to control everything within GitHub with a pull request, which was super nice. But this leads to my favorite Amazon quote, I think, of all time. We could solve this now or just wait 6 months and Amazon will provide us with a solution. So they actually released the Amazon Shell ETL script job. So what that is it actually hooks in with the your already existing Glue ETL jobs and just runs arbitrary Python code, which would have been super nice for this. You could kind of hook that in with your schedules for your ETL jobs, and then off you could go. So that would have been super nice. Maybe next time I'll just tell my CTO, maybe I'll just wait 6 months before I actually do anything. Yeah, so finally, our last like kind of issue that we had when creating our Redshift cluster and our data warehouse was that we wanted to give access to our BI tool outside of Amazon. So we use Looker for our BI tool. Sorry, Amazon, we don't use QuickSight. And what we found was they don't really give access to they don't have ability to connect to a Redshift cluster that's inside of a private VPC. So what we ended up doing was this solution using PG Bouncer, which is a Postgres connection pooler. And so what we did was we used that to basically allow a pass-through for our just certain credentials from our Looker user. And so if they're using the correct credentials from outside of our Amazon account, it will allow that to go through to our Redshift cluster and give the connection. So that way any of our internal views that we don't want outside access to are still within our private VPC Redshift cluster. So what's next for the Genera data warehouse? We have a few things that we're currently thinking about using moving forward. So one of the things that Jessie talked about a little bit was we initially started our data warehouse using Redshift Spectrum, and that was taking a really long time. But what we've heard from Amazon is some of the feedback that we've heard is that it's gotten a lot faster, and if we can use that to query our S3 data without actually needing to load it using an ETL process, that would be super nice from our end, just because it's one less thing for a small team to manage. But if that doesn't end up working out, we will probably take a look at AWS Lake Formation, which is a preview service that they announced that kind of combines all the data from all of your databases in S3 locations and centralizes it in one spot for making it easier for ETL processes to reference it. So that's still in preview. We're kind of letting it gestate for a little bit, and then we're going to give it a go. And then another thing that is kind of on our radar, if that doesn't end up being working out for us, is kind of creating our own process to do the same thing with Apache Airflow, which is an open source orchestration tool that can kind of orchestrate a bunch of different Python scripts to kind of do the same thing that Lake Formation would do, but running it ourselves. So that's another option if that doesn't end up being the same thing. So in summary, Glue has been a super invaluable tool for us to create our data warehouse. We've, despite having a really small team, we've able to, process tons of data and give really good value to our business team. And so, despite some of the growing pains that we may have felt while using the service. So when we first started researching Glue, we were greeted with things like this on the Amazon forum. And like just to highlight the very immature early stage product, but that was like kind of some of the initial feelings that we got. But after some of our workarounds, it's really helped us, our team, enable the construction of our data warehouse. So finally, some of the links for the different open source custom Lambda partitioner, and also the retrying PySpark code in a gist. So thank you very much. And we have time for questions too. Do you guys? I think we can hear people pretty well if people want to shout out things. Any questions? Would you do it again? Yeah, I can speak from the ops perspective, but maybe Jessie has a different opinion. But I think, doing it again now would be a lot easier. Just because of some of the tools that they've released. We didn't have to do a lot of the things with Zeppelin that kind of, caused a lot of pain points and cost. So I think doing it again now would be about 10 times easier, so.
Yeah, I think any ETL tool is going to have its own idiosyncrasies and problems. I think managing PySpark, or at least AWS's version of managed PySpark, unlike Databricks that has a lot of proprietary latest and greatest features, makes working with Spark more difficult. But also Spark is kind of just difficult to work with anyway because it has so much overhead as a framework. So I think maybe part of the question is, do you have a better ETL option than Spark?
I see a hand somewhere.
Question is, we had data lake formation as a future state part of your stack. Where do you see that fitting in when you already have data lake already there?
So we have a pretty heavily changing data set. Our data structure kind of changes a lot. And so one of the things that we saw with data lake was the ability to put everything in one spot before you run ETLs on it. Which is, at least from my reading of the documentation so far, kind of the advantage that they would have there. And so in that way, at least from what I've seen there, is that it makes changes to your data set a lot easier. So that kind of putting it as a precursor to some of the ETL jobs that we already have, just to keep the, kind of the sanity around your data.
I think that's it. Thank you all.
And we'll be around if anyone has any questions, so thank you again.